For the last few months, I've been teasing a big upcoming project where I convert the budget Sovol SV08 into an all-out, no-holds-barred 7-tool-head monster. And I'm pleased to report that just about all of the parts have finally arrived for the build. So in this video, I'm going to outline the project goals, explain which parts I chose and why, and share how you can follow along as we get this thing built. Let's get after it. So first of all, what are we trying to achieve with this project? Well, to be completely honest, I've never had any Toolchanger 3D printer whatsoever before. So the primary objective is just going to be to get me to have a printer that can do full multi-material in addition to multicolor 3D prints. And if I'm completely honest, I definitely have to thank Michael Laws over at Teaching Tech for actually inspiring this entire project, because although I definitely did plan to upgrade the SV08 from the get-go, the thought actually didn't even cross my mind to convert it into a tool changer until he did it. And I'd been putting off building a tool changer because I really didn't want to go through the massive time suck and hassle of building yet another Voron, especially after how many weeks I sank into recently building the Enraged Rabbit carrot feeder. With that said, I do want to put, of course, my own spin on this project, and I also don't have a Prusa XL like Michael does, so I actually have quite a few different requirements as this is my first tool changer. First of all, I'd like to try and have more than 5 tool heads if possible, which will allow me to do much more complex multi-material and multicolor 3D prints, or mix multicolor with multi-material if I so choose. Second, I want to have a little bit more flexibility than just 5 exact copies of the stock toolhead, or of any one toolhead setup for that matter. For example, I want to have different choices of different hot end types, different extruder types, so that I can mix and match different toolheads and extruders and hot ends that are each going to be better for abrasives, or better for flexibles, or better for any given thing. And third, I really don't want to constrain myself to be on a budget here. While I love Michael's idea of making an approachable, affordable, and budget tool changer, because I don't already have a top-of-the-line ready-made tool changer, I want to really spoil myself here. I want to emphasize quality components, and I want to make this thing perform the absolute best that I possibly can, which I'm sorry, Sovol, means ditching the proprietary stock hot end and that big bulky tool head. So those are the kind of goals of the project. If I had to summarize it into a TLDR, I want to build a top-of-the-line dynamic tool changer that is well-equipped to handle any combination of any filaments that I want to throw at it. First things first, let's talk about how we're going to make this single head printer into a tool changer. To do this, I'm going to be relying on the hard work of the DraftShift team, makers of the StealthChanger project, which itself is originally based on the TapChanger project. For those of you who don't know about either of these already, the StealthChanger is a system that allows you to convert typically a Voron 2.4 into a tool changer by adding backplates and docks for the tool heads. It's currently compatible with a whole host of tool heads, from the Stealth Burner and Dragon Burner to more obscure ones, and they enthusiastically welcome user mods to be submitted on GitHub if you want to adapt the system to other tool heads as well. And that's going to be important for us as we talk about my choice of the toolhead design. Like Michael, I'll be relying on an additional 2020 aluminum extrusion and some quick adapters to create a docking bar for all the tool heads to actually go on, since the SV08 does not use the standard aluminum extrusions that you would find on a Voron. For the tool head, I wanted to go with something new and unique for really a few reasons. First of all, as you might recall from my open letter to the 3D printing community that I put out earlier this year, one of my goals as a content creator who is blessed to have this platform is to highlight some of the lesser known and up-and-coming projects and designers and use my platform to shine some light on the awesome work they're doing so that hopefully they can get supported, get people supporting them on Patreon, and maybe even transition to full-time if that's something they want to do. Speaking of people who want to transition to full-time creating and designing for the 3D printing community, Many of you have probably already seen some of the incredible work that designer Nadir has been doing on designing improvements for the SV08, the SV06, and lots of other printers. So for me, it was a really easy decision to use one of his Toolhead designs instead of some of the more popular and already famous ones like the Stealth Burner or the Dragon Burner. Together, Nadir and I decided on this Spartacus Toolhead design, which itself is based on the mini Stealth Burner and as a result is free and open source for the Bondtech BMG version. Now, this has a few benefits over some of the other Toolhead designs that have already been adapted to the Stealth Burner. First of all, it's much lighter and much smaller and much more nimble than the massive original Stealth Burner, which hopefully will mean better speeds and accelerations once we get this thing running. Second, it is smaller in size, which means that you can actually fit more of them, in this case 7 on a 350 build volume, than just about any other Toolhead design out there. Third, according to Nadir, it offers significantly better performance and cooling than the mini Stealth Burner, which although he admits he hasn't tested in a very scientific way, honestly isn't saying all that much if you've ever used the mini Stealth Burner. No offense, but it really is typically designed for ABS where cooling isn't such a big deal. So that's the Toolhead design that I chose to go with, and you can see I put a small selection of them on the table because if I put all the parts that I had to print out, I wouldn't have room for anything else on the table. I chose to print the parts out of a combination of Polymaker's Polylite Galaxy Gray ABS with Polymaker's Polylite White ASA for the accents. And I think that this color combination turned out absolutely great, and I love how perfectly it fits with the shiny, glittery type extrusions of the Sovol itself. Now let's talk hot ends. And as I mentioned, I want to choose a careful assortment of hot ends that each gives me a different benefit and a different capability. Recently, I did a video about the Revo ecosystem from E3D and how over time I've been more and more sucked into the wider Revo universe just because of the extreme convenience of having all my different printers of all the different brands running on the same nozzle with the same height. Kind of like all my printers used to use the V6 standard before some companies out there started making their own proprietary nozzles. So based on all that, it probably comes as no surprise that I chose to equip 4 of the toolheads with the Revo High Flow hot end. In fact, if anything, you might actually be surprised that I didn't choose to make all 7 of them E3D Revo. After all, E3D has been kind enough to send over a bunch of hot ends, and I have all the different nozzles that I could possibly want, from the high flow brass to high flow obsidian nozzles, diamondback, you get the idea. But as you might also recall, even the highest flow version of the Revo high flow ecosystem is not the fastest flowing hot end out there, and you do sacrifice some performance for the convenience you get. So I decided to just do 4 of the toolheads with Revos, which on the one hand will be really good for rapidly changing a bunch of the print heads if I want to switch the entire printer over to 0.4 or 0.6. But up next, let's talk about fiber-filled filaments, something I'm really looking forward to printing much more of in the future, especially with Polymaker recently announcing an entire line of fiber-on filaments that I'm really excited to try out. So for these filaments, I decided to go with the Drop Effect NextG fiber. Yes, I know that most of the wear on the hot end is right at the nozzle, and I could easily make most hot ends compatible with fiber filaments by just throwing a Gamma Master or Diamondback nozzle on there, but I do worry about wear in other places, and I like the idea of having an RNC-coated heat break and just a hot end that is designed from the ground up to handle super abrasive filaments from the top to the bottom. Then, for really high flow, high speed prints, for example, printing ABS or really fast, high-speed PLA, I decided to go with 2 other hot ends. Only one of them has arrived so far, and that's the Fadis Rapido 2 Ultra High Flow. And then the other one that I'm still waiting on is the Slice Engineering Mosquito Magnum. Now, these both offer really high flow, especially in the case of the Rapido, and I like that these ones utilize my existing V6 nozzle collection, and they give me the ability to test new nozzles out against others if, say, Bondtech comes out with something new that demands a V6 hot end. Now, I chose the Rapido 2 Ultra High Flow because it is one of the top performing hot ends out there in terms of high flow, unless you go down the rabbit hole of kind of really esoteric, custom, water-cooled type hot ends. This is a really high flowing one for something you get off the shelf and is supported, and there are designs available for it. As for the Slice Engineering Mosquito Magnum, because they are one of the few companies out there that manufacture in the US under very strict quality standards, I've been toying with the idea of just using that hot end as an untainted, pure, clean hot end for food-safe filaments and prints, things like non-oilin or food-safe rated PETG, for example. But I'd love if you let me know in the comments below what you think about my entire hot end selection and that decision, and also what you would use each of the different hot ends for. By the way, now is probably also a good time to mention that just about all the parts for this build have been provided free of charge by the different brands that I'm mentioning. So thank you to all of these companies and the ones coming up later in the video for sponsoring this project with everything I needed to do this build. Also, I do need to give a special thanks to Sovol, not just for sending over the printer that would later become the basis of this project, as well as a bunch of accessories that we're going to talk about, but also for sponsoring this video. You guys have heard me talk about Sovol many times before. They are my favorite pick when it comes to budget-friendly and open-source 3D printers. So whether you opt for the SV08 as the basis for your own Toolchanger or just upgrade project, you go for the Comgrow T300, which they also sell and is a super sturdy workhorse printer. Know that with Sovol, you're getting an incredible value for your money, and I personally use and recommend their products, and my comments are always flooded with people singing their praises. So to check Sovol out and support the people who make these videos possible, do visit the link in the description or go to jle.vi/Sovol today. All right, let's get back to the video. Okay, so we talked about the hot ends, but how are we going to actually push filament into them? Well, fortunately, here too, we can mix it up and not be married to just one design. Not only does Nadir have a design that makes use of the kind of standard off-the-shelf Bondtech BMG extruder gears, but he also has a design that makes use of the lesser-known Bondtech LGX system, or large gear extruder. This is cool because, as you'll remember from some of my recent videos, I really do want to experiment not just with multi-material TPU and TPE prints, but I also recently picked up some super flippy-floppy 70A and 75A TPU and TPEs that I had a real hard time printing with my current lineup of printers. So I consulted with the fine folks over at Bondtech, who you can add to the list of people who sponsored this project with products. And together, we decided to go with 5 standard BMG tool heads and 2 LGX ones, because it is unlikely that I'll ever want to print more than 2 colors of flexible materials at once. And even if I do, the BMG still can handle some level of flexible filaments. It's just not as confident in doing so as the LGX. As for the motors and the hardware and the fans and all the little small detailed things, it's no surprise here that I went with LDO motors, which Jason over at LDO was kind enough to provide. Personally, you guys have seen me build multiple LDO kits. I've done the Voron 2.4 and the 0.2. I think, honestly, anyone who has ever built an LDO kit will agree that they really do make the best quality components and upgrades. So it was clear to me who I wanted to work with in doing this build. By the way, LDO is also really good about making super high quality kits for open source projects like Vorons and the ERCF, the Positron, and they might even be working on a StealthChanger project. So if you'd like to build a Toolchanger based on Nadir's toolhead and designs, spam the comments below and let Jason know that he should also offer a kit for that. Okay, so those are all of the mechanical parts, but now we need to figure out how to actually make them all work together. After my recent struggles with some CAN bus wiring and not having enough fan ports on some of the more common CAN bus toolhead boards, I decided that this build would need to be a little bit different and a little bit simpler in terms of wiring. First, since the SV08 actually already communicates with the toolhead over the USB protocol, it's a shoo-in for using a proper USB toolhead board which it just so happens LDO Motors has recently developed and released. So Jason was kind enough to send over 7 of the Nighthawk 36 toolhead boards, which include, thank goodness, all of the professionally made and crimped cables, because, let's face it, my history of crimping CAN bus connectors is not good. As for the main control board, I actually want to try and use the original controller board, but I do have some spare boards here from Mello, Big Tree Tech, and MakerBase, just in case I can't get things to work smoothly. Then, for connecting A to B, C, D, E, and you get the idea, we're going to use just a cheapy powered USB hub that I bought on AliExpress, though I am eyeing the specialized board that Michael is using in his build, in case this doesn't work as well as I need it to. Finally, let's talk enclosure and screen. To be honest, this is the thing that I've probably put the least thought into, and I think I'm honestly just going to end up using the ones provided by Sovol, albeit with some modifications. I will need to, for example, modify the screen mount using Nadir's model, and I'm pretty sure that in order to make room for the tool heads and wiring, I am going to need to print the riser that Nadir sells on printables. Now, I'm pretty sure that that covers it for hardware, besides some little odds and ends. For example, I was just going to route the cables using PTFE tube and use that as kind of cable support, but I'm sure that there are blind spots that I'm not seeing. And because Nadir is a new dad and he just hasn't had the time to actually get around to building his own design yet, I'm kind of the beta testing department on this one. So do let me know in the comments if I am missing something or if I have a blind spot that I'm completely unaware of. All right, so now that we've discussed all the hardware and I have almost everything here and printed, let's talk about the next steps and the plan of attack here. Rather than do what I just about always do and bite off more than I can chew, I am going to start by building just 1 or 2 of the tool heads and actually getting them mounted to the printer, wired up, communicating with the board, and all that different stuff. Some of you know that I have a tendency to avoid and procrastinate all of the electronic and software stuff and escape into the mechanical stuff in the building that I genuinely greatly prefer. But on this project, I really just don't want to dig myself into a hole so deep when I don't know if everything is actually going to work properly. I am going to do my best to build all of this project across a series of live streams. So if you do want to check in on how I'm doing and give me a little bit of support, click below to visit the channel and then go to the live tab, or just make sure to hit the bell icon below to be notified when I go live. As you guys know from past projects, I really appreciate the support and the company when I take on these massive multi-day builds, so I'd love it if you guys drop by. And now it is time for me to get to work. So that's all for this week, but I'll see all of you on the next layer. Where am I gonna start with this?